Hello everyone, my name is Abdel-Rahman, and in this video I will be continuing what I've started with dosrznrc. In the previous video I just ran the dosrznrc template file just to show you how to launch a simulation and how to see the results of that simulation. Today I'm going to talk about how we can define the RZ geometry as well as to assign medium to different regions in that geometry. So to begin, let's open those XYZ file, and I will just make a new file here, call it a name. I'm going to call it cobalt 60 since that's the beam we're going to be using in this demo, and underscore, and I want to get a PDD for cobalt 60, and I'm going to save the file, input file. Now the PEX data file here, I'm using the default one, 521 ICRU that's available in the enhanced directory, but if you have made your own PEX data file, you can use that. So for example, I will go to my EGS home directory, and then when I click on this button, then I will get all the list of available files that I have in my home area. So for example, I have one here, it's called Phantom, and that PEX data file has water as well as a lot of other media of interest. So the tab I'm going to talk about, it's actually under geometry, and here is where we can define the dimensions of the regions in the RZ geometry on the left side here, and on the right side here we can then assign the media to different regions in our geometry. This is explained in their if you go to their website and open their manual, you'll find a very nice explanation here. So the manual, it's RZ, this is the manual, and when we open it, it describes a lot of things about the RZ user codes, and the dosrz is one of them. So just to give you an idea of this RZ geometry, the RZ geometry is best used for obtaining beam data on central axis. So a PDD is a very good example of such data. There are several user codes that use the RZ geometry, dosrz, NRC, fluRZ, NRC, SPRR, ZNRC, and CAV RZNRC. So within RZ geometry, the assumption is you have a cylindrical symmetric phantom, and this phantom can be visualized being made of a central cylindrical discs surrounded by rings. This phantom is divided into regions or slabs and so on, and my aim in this video is to show you how you can actually define the dimensions of these regions and then assign medium there. So the top view of this RZ geometry, imagine you're looking at the phantom from the top. What you're going to see is just rings. You will only have one option to define the dimensions of the rings, is just by specifying the radii of these boundaries. In this example, there are 4 regions. So the inner one, that's the disk, and then we have 4 rings surrounding the central disk. Now from the side view, those are the layers. So in the RZ geometry, we can also define the phantom into different layers, and there are 2 available options actually to define the layers. The first option is called individual, and basically the one specifies the boundaries. In this case, we have to specify Z1, Z2. For example, this could be 1 centimeter, this is 3 centimeters, 4.5, and so on. Or another option, which is often quick, especially if you have a lot of these dimensions of the slab are the same. So it's called a group method, and there one specifies the number of slabs and their thickness. So an RZ view will look something like this. Since this is a symmetrical geometry, so the cross-section view of it, we can just display the radius as well as the depth or boundaries slabs. And these are the regions. So now if we define the different radii as well as the different slab thicknesses or depth, then we have these multiple regions. Here is where you're going to select the input method. So if we decide to use individual, then we have to then specify the boundaries of the slabs. So if we want to get a PDD 5 millimeter depth, let's say resolution, then we probably need to put and suppose we want to do that up to depth of 30 centimeters, then we need to specify probably around 60 different boundaries. So this will be 0.5, 1, 1.5, and 2, and so on. And that's why the second method using the groups is actually simpler. So in that case, I would say, look, I have 60 slabs and the thickness of the slab is 0.5, and that's it. We don't need the rest. Save, and let's save it, and we hit on preview. So this is the slab, and in the Z, just increase the resolution. So we have here, these are the 5 millimeter slab thicknesses. So coming back to here, since we want to get a PDD for cobalt, probably want to have a good or a fine resolution near Dmax. So I'm gonna specify I want 10 slabs with a thickness of let's say 0.1, and then another 10 slabs with a thickness of 0.5. So the first group will give me a total thickness of 1 centimeter, and then we have a second group, we have 5 centimeters, so the total thickness now is 6 centimeters. So maybe we can put another group. I can put this to be 15. Okay, and let's put 1 centimeter and another 15, and let's put this to be 2 centimeters. So we have, this is 30 centimeters and 15, 45, and then 5, so that is 50. So the total thickness is going to be 51 centimeters in this case. So we can view it quickly. Sorry, we can preview RZ, and you can see the maximum or the last boundary is at 51 there. And we have finer resolution near the first 1 centimeter and so on. Now the radius, since I'm interested in PDDs, so probably I need to have just a radius in the center of 0.5, and we can delete those. Since I want a large phantom, I'm going to put this to be, let's say, 30 centimeters. And let's save. And we preview RZ. So we have here in the center, let's increase the resolution. Okay, so we have this radius. So the inner disc has a diameter of 1 centimeter. And then we have the outer ring will have dimension of 29.5. Now we go to the next part, is how to define assign the medium to the different regions. So these are the regions, and now we go to assigning. Okay, so assigning the medium, there are two methods. One is if we go to the user code, the first method is going to be by regions. And basically, if you look at the manual, okay, this is the convention how of assigning medium. So the way you have to look at this now, this is the top view of the RZ geometry. This is the top. So outside of the cylinder, that is region 1. And then along the central axis, we start to have region 2, 3, 4, up till until then we have the number of slabs plus 1. So in our case, I forgot we had 15, 15. Let's look at it. Okay, so we had 15, 15, that's 30, 30, so 50. So that means we have along the central axis, we have this will go from 2 up to region of 51. And then our rings will start at region 52 and so on. So here I have to assign, select the medium, and if you click on the arrow, you will get the list of the medium that are available in the PEGS data file that you have selected. So in this case, we want to have water, H2O 521, and there we can specify from which slab start to end, and also start to end the rings or radius. So here we're assigning it since I have 50 slabs, a slab from 1 to 50, and then radius is 1, I have 2, then we'll put 2 here. Okay, we don't need this one. Okay, but okay, it's a bit hard to I don't know how to delete it from the GUI. Let's try and see if this works. Okay, okay, I cannot delete this. Okay, but I don't think it's a problem. So if we save it and we preview the RZ geometry, then you'll see that all the regions were assigned water, medium water, H2O, so it's in red, and all of these regions are in red. Now, since I have this material, suppose I want to have, let's say, some slabs, inner slabs, I want to replace them with water, put air there. So let's put from, let's say, slab number 10 up to 15, and this, since we want it to be in the inner discs, so this is going to be 1, 1. And let's save, and let's see what's the geometry, how is this going to look like now. So as shown here, these slabs or these regions now, the medium that are assigned to them is air 521. But since I want a PDD, I probably we can delete those because I want everything to be water. Notice that the way the code is going to fill the medium is it's going to read these lines sequentially. So for example, if I put here, let's put that again. So let's put 10 up to 20, and then 1, 1. And suppose we selected a different material now, and let's put bone. Okay, and let's put 1. So let's put bone, and we're going to start region 1 up to let's say 40 or 50, and then 1 and 2. So the way the code is going to interpret these numbers is first is going to fill the regions with water. These are the regions that will be filled with water, and then it will go to the next line and then fill these regions defined by star Z stop Z, start R, stop R with air. So if that initially the regions were assigned with water from the first line, but now it's going to actually assign a different material there. And then on the third line, now we're assigning everything back to be bone. So the overall or the result of this is that we're going to have a phantom that all the materials are going to be bone. So this is water, air, so now everything is bone. So be careful when you use this method, and that's why I suggest you always constantly preview the RZ geometry. And so probably don't need this, or I can just replace it. I'm gonna put it back to water. So because I don't know how to delete the line from the GUI, does not matter. Then these are, I mean, everything is just going to be replaced by the last statement. You can always go to the input file from using a text editor, and you can delete those materials. Probably in Windows it works, the GUI in Windows might work, but on Linux I'm having trouble doing that. So we're going to save this. I'm just input output Monte Carlo. So I have here 1 million particles, and I'm going to leave the source. I know the source, this is cobalt. And so let's execute and run the simulation. Since I have a parallel processing multi-core computer, I'm going to use batch and split this into 8 jobs, and we're going to run it. So now we're going to see that my CPUs are all busy doing the calculations. Yes, the calculation is done now. Let's open the terminal and we'll go to our home area, and we're going to use EGSnrc. Cobalt 60 PDD and underscore the DD, plot that. So this is the percentage depth dose. This is the percentage depth dose along the beam central axis. This is actually the dose from the surrounding rings, because if you noticed in the plot control we had here to region 2, so we can remove this, and let's just restart Monte Carlo. So we'll do another million, and in the input output control, instead of first, I'm gonna select restart. Remember to always save and then execute batch 8 and run. Okay, and done. So repeat this command again and open the PDD file. So this is now the PDD file for Cobalt 60. Of course, if we need to run more and more simulations to get a smoother PDD curve. One thing I forgot to mention probably in the last episode regarding the plotting, we have two options to plot. One is to get a histogram, or I prefer to always have a point plot. And remember that the doses are recorded in the center of the region, okay, or center of depth. Especially because we're talking about PDDs. So since my first slab is going to be 1 millimeters, then the dose will be reported at 0.05 millimeters. So let's save this, and again let's accumulate more. So with Monte Carlo we can just execute again and run. So now we don't get a histogram, but we get like a plot, points x and y. And if we look at the file, it's just a text file. So here, this is the first depth recorded, which is 0.05 millimeters. This is the dose per incident fluence, and this is the statistical uncertainty. So roughly we're at 10% statistical uncertainty of the value. You will need to run more particles, and of course for larger regions the statistical uncertainty is lower than for smaller regions. So probably you need to run more and more particles to get better statistical uncertainty for the results. I hope this demonstration for the RZ geometry was useful. And in my next episode, I will talk about, I will explore the different source options. That was going to be this tab here, the sources. Until then, I hope you enjoyed this video. Please leave comments and subscribe to this channel. Thank you very much.